Alright guys, today we're going to be learning about a regression analysis, and we're going to be using Excel and R to do some examples about this regression analysis stuff. We are not going to go too much into the mathematical equations that go into how these regressions are calculated. I really want you to understand really what those numbers means once you get a regression analysis. So regression analysis goes back to understanding this issue of cause and effect type of thing. So basically, if you are changing one variable, what is the effect of changing that variable on another variable? So that's what regression analysis try to do for you, to quantify the magnitude to which changes in one variable will influence the other variable. Regression analysis there is really your friend to understand these kind of processes. All right, today we want to do a quick example about comparing some socioeconomic data that might or might not be related to each other. And so for that, we're going to look at, again, some socioeconomic data. The main sources of socioeconomic data are the World Bank. The World Bank has, again, is one of the largest databases of socioeconomic data there. And this is the web page there. You can here look for any kind of data that you want to look for, GDP. And then you get it by country, series, specific time, and it shows up over here, right? And then you can download this data here, Excel, CSV, any way you want it. That's one of the main sources of data. We already look at this one, which is the CIA World Factbook. Here you select one country. It will give you all of the information for that one country. But when you look at a given indicator, you have this option here. You click on it. The CIA World Bank will also give you the GDPs of all of the countries that they have. So that's another important source of data. And finally, another one that I like very much is this one called Nation Master. And you can just pretty much select any socioeconomic data that you want to look for. Here it gives you the first link, countries compared by economy. Basically, it gives you the list of countries by GDP in here. And you can again just look for other metrics that you want to look for, and you will get all of that data. One final web page that I find very interesting is this one called Gapminder. Just search it quickly. This thing is not really that great on the mouse. Oof. Just look for it. Gapminder.com. Right there is the second link. You scroll down, you will have this one here that is called Play with the Data. You click on it. This is a very nice web page. I like it very much because it allows you to actually not only get the data that you want, but also look at it and change it here. For instance, you can play it and you can see the relationship. Let's just look at this correlation, by the way, between life expectancy and the income of people, how much money people make. So this is something that is already right there on the web page. So you look at this trend, it seems again that countries that are making a lot of money, where people is making a lot of money, that people is living longer, while people that is making really not a lot of money, that people is living shorter, right? Like people in Ethiopia, they only make $653 per year. On average, that people only live 47 years. While in the opposite, we had maybe this country here like the United States, where the average people make close to $40,000 and we live 74 years. So you look at this plot, you can assume, okay, there seems to be a trend there. And again, it makes sense that people that makes more money can live longer. Obviously, we can assume that people with more money will have access to more resources to live longer. The opposite is for people that don't make any money. Now, the coolest thing about this Gapminder is that you can actually select the variables here. So you click in here. Let's look at this one, for instance, CO2. And you will expect that CO2 will relate to GDP, right? So that people that have more money will produce more CO2 right here. This is money, this is CO2, but you can see that in all of the countries there seems to be no correlation. So that's one of the first things about the use of regression analysis when you are comparing this data, is the fact that maybe the relationships are not in a nominal scale. And again, one of the coolest things about Gapminder is that it allows you to change between linear and logarithmic. So basically you click log, or what it does, it changes the variable to a logarithmic scale. So what happens here, if we change it to a logarithmic scale, now you can see that now there seems to be a trend, right? People that makes more money produce CO2, but now because we change this scale to logarithmic scale, what that tells you though is that by the same amount of money that people make, they don't produce the same amount of CO2. Basically what happens is that as people get richer, they produce a lot more CO2, right? So it seems that it's not proportional, and again, that's the result of you setting this scale here in a logarithmic scale. Again, you can play that over time just to see how the correlation has changed over time. And you can see that usually, by the way, I think this is probably China right there. You can see how China is making more money. It's pretty interesting, eh? Like there's people there start making more money, but they of course start producing more CO2 right there. It's probably this is India again. I mean, as you can see, it's pretty neat, this web page, because it allows you to see those changes over time. And there you can see, for instance, how China and India are really one of the biggest problems for climate change, because obviously they are making a lot more money today, but because the amount of CO2 that is produced is a logarithmic function of the amount of money that they make, obviously you have all of the people there making a lot of money. That means that the impacts on climate change are going to be massive. All right, let's just get to as you can see, I mean, all of the things that we have been talking at to this point are just pure speculation, because there is no numbers there that allows you to establish that correlations between this variable and this variable here. So what we're going to do today is actually get some of this data and play around with some of the calculations that will allow you to establish actual numerical relationships between these variables. So we're going to go to the World Bank database, and we are going to get the data on percent land crop, permanent cropland. Again, just go there to the World Bank. We're going to be looking for permanent cropland is the first variable there, the percentage of the land that is occupied by agriculture. You are going to select it right there. So it's right there, permanent cropland. All what you have to do is click download, and we are going to download that as a CSV file, right? Now the other one variable, click in there, that will download it for you. I already downloaded it. I'm not going to download it again. The other variable that we want to look for is population. We're going to see the density of people on different parts of the world. So here you have it, population density, people per square kilometer of land. So you select that. This is, again, you can see it over time. You can see that over time, the density of people is increasing quite dramatically. We can download that again as a CSV. Once you do that, those files are going to be located in your downloads folder in my case, are these two zip files there. If you don't have a downloads folder, go back to your Firefox. Here in Tools, look in Options. And here on General, you will see the place where the downloads are being saved, right? So in my case, again, that's in that folder downloads, but maybe you had a different way where your data is being saved. But if most likely you already had that pre-default in your Windows. Anyway, so those are my two files there. This is the population of the world, and this is the agricultural land. Unzip that, and that will show you these three files here. So again, this is the folder containing all of the human population. You can tell by the size of the files that this one that is bigger usually probably contains the data. You open that file. What we have here, let's make this thing a little bit bigger. So here what we had is, again, the list of countries in the world, from Aruba all the way up to Zimbabwe. We had the name of the variable, which is population density, and we have all of the data, all of the years for which that data is available, right? So what we want to do, I just want to select maybe the year 2010. The way to select just those two columns, obviously we want to select these first three columns, right? We want to keep the name, the abbreviation name, and the variable, and we want to select a given year. So in Excel, the way that that's done is by pushing the key Control, and then while holding that key push down, Control, then you push on the column, right? So that will allow you to select these three columns plus that column there. You can right click and select copy, and that pretty much copies for you those four columns there, the name of the countries, the variable, and the data for that given year. All right, but as I say, let's just do that for a more recent year. Let's collect the data 2010, select the first three columns, push the button Control, and select that year there, the year 2010. Right click and copy. Let's open a new workbook, and let's paste that data in there. So again, here we just had the data on population for the year 2010. Let's do the same now, but for the area of cropland. So go back to your downloads folder, and my folder containing the cropland data that I just downloaded is on this folder. Again, if you look at the three files that were downloaded, the biggest one is the one with the data. Double click, open it, and again, from here we just want to collect the first three columns and the data for the year 2010. Push Control copy, and now go back to your workbook one, the one that you just opened up, created, and paste that data in here. So what we have here are the two variables that we want to compare. Again, this is the number of people, and this is the amount of cropland that is being occupied in the given country. What we want to do is to actually pair these two databases. Obviously, in this case, they seem to be paired up already very well, so you can just pretty much copy this column and paste it over here. But obviously, if there is one country missing in this database, you might get a huge problem there, because the data on population wouldn't be the same for the same country there. So what we are going to do here is try to bring the data on permanent cropland into this database of population density. For that, you're going to use a function that is called VLOOKUP. So equal VLOOKUP. VLOOKUP asks you, okay, the first thing that I ask you for is that VLOOKUP value. So what do we want to look for? Okay, I want to look for the name of this country, push comma. Now the table array. Table array is where do you want me to look for that country. So here you select the three columns, starting with the column. The first column on that array has to be the column that contains the value that you want to look for. In this case, is that column J. and obviously you stop in the column that you want to get the value from, right? The third thing that you need to enter to this function is the column index number, which is basically, okay, if I find this value or this country, I find it on this row, on this database that you asked me to look for, what value, the value of which column do you want me to return to you? So in this case, we want the data on cropland, which is located on the third column, 1, 2, 3, right? So the column index number is the column third. The next thing that he asks you is, do you want an approximate or an exact match? In this case, we want the name to return exactly the value for exactly the same country name. So we are gonna type false. And then we click enter. So again, here, if I look for Aruba, which is the abbreviation name is this, and I look into this database, the cropland for Aruba is 0. Basically, there is no data on cropland for Aruba. You can see there that that value is empty. So I can just double click in here to extrapolate the same calculation for all of the countries. And right there, you can get the area of cropland and the area of the number of people for all of these countries. So we can pretty much name this. So this is population density. And this one is going to be cropland, right? And those are the 2 columns that we want. We can pretty much just select those 4 columns just to move somewhere else. So we can clean up this. We can paste as values there. So here we have the data that we are looking for. We don't need this column anymore. So here we had the list of countries, their abbreviation, the number of people on those countries, and the amount of cropland on those places. So every time that you want to look for correlations, the first thing that you need to do is to plot these variables. It's always good to get a visual inspection of your data. So here you select the 2 columns, you go to insert, and we're going to do a scatter plot just to see how related they are. So here on the y-axis, you have the amount of cropland, and in the x-axis, you have the number of people. As you can see, there seems to be no correlation whatsoever there. There is no really a trend that you can see from this pattern. So the first thing that you need to do is to look for the possibility that the relationship between these 2 variables is not linear. Right? For you to explore that possibility, just double click here, the x-axis, and Excel allows you to have this function of looking at that axis in a logarithmic scale. So you select there, click close. Now that will put the x-axis in logarithmic scale. So still you don't seem to see a nice pattern there. Let's do the same thing now for the x-axis, for the y-axis. Now it gives you this error, right? Negative or 0 values cannot be plotted correctly on log charts. Basically, what that is telling you is that in our database there are some values that are 0, and obviously the log of 0 is an error, and that's why you are getting this error here. So the next thing that we need to do then is we're going to delete the zeros from this database. So we're going to select the 4 columns, go to data, and sort by cropland from the smallest to the largest, and that will put all of the zeros right there at the beginning of your database. So we're going to delete all of those values that have zeros, select them, right click, then you click delete. Let's just check the possibility that maybe there is a 0 on population density. So go to data, sort, but we are not going to sort that by population density from the smallest to the largest. And you can see that the smallest value density is in Mongolia, which is about 1 person per square kilometer, 1.7 person. So there is no 0. So we already pretty much got rid of the zeros there on our database. So all of our cells are now complete. We can again go and explore the regression between those 2 variables. There seems to be no correlation. So I'm going to do the log scale on both axes. Now this is interesting. because now you can see that there is a trend here, right? The interesting part of this trend is the fact that the correlation was not in a linear scale, but in a logarithmic scale. What that tells you, again, as we explained earlier, is the fact that the amount of area that is occupied by agriculture is not going to be constant depending on how many people you have there. Obviously, in this case, what is happening is that a country will only have 100% of area that they can occupy with agriculture. So there is going to be a moment in which, regardless of how many people you have on a country, they can only get up to the maximum number of the area that they can occupy. And that probably explains to you why this trend is better described in a logarithmic scale than in a nominal scale. All right, but again, keep in mind, all what we had done up to this moment is just to look at this from the pure speculation side of stuff, right? We're just looking at this figure and we are explaining these trends that we are seeing there. Obviously, that's not gonna be of any valid, that's not gonna be valid at all. You need to really put some numbers on these patterns just to demonstrate, to document really where these things are related to each other or not. For that, Excel allows you right away to look at the correlations. If you go to layout, trend line, more trend lines, here in this option you can get the display the equation and the R value, right? And here is the different types of models that you can apply. The linear model is the first one that we are doing, but keep in mind that because we log transform both axes, that is what is called a power model. So you select the power model, and there you get your regression model. So again, this is what is called the regression model. It has this first parameter, which is called the intercept sometimes, and this other parameter here, which is the slope, right? But keep in mind that this is a power model. So basically it's telling you that the amount of cropland y is equal to this parameter times how many people is there to the power of this constant value. So you can always predict the amount of cropland, which is this axis here, as a function of this mathematical equation there. Now, the other interesting thing is the R square. The R square is the proportion of variance of cropland that is explained by the number of people. In this case, that value is 0.4. The way to interpret this number is that 40% of the variance in the amount of cropland can be explained by the variation in the people that lives on that country. That is, of course, assuming this logarithmic scale, right? So keep in mind, 60% of the variability in a given country still remains to be explained. And obviously what happens there is that other countries, like whether the country is developed or where they have good conservations, probably all of these things are going to influence how much of a country is occupied with cropland. But right now, at the most basic level, 40% of the variance in cropland can be explained by how many people you have in the country, and this is the mathematical equation that defines that. Again, this is what is called descriptive statistics, but you just don't really know if this is something that will be normally expected by random or not. So you still need to get a confirmation of the significance of this correlation. Will this be a pattern that you will expect to see by random there? So that's where we are still missing some additional information, which is the p-value. So, and that's where Excel also allows you to do that kind of stuff. If you go to data analysis, here you had different types of statistical analysis that R allows you to do. One of them, again, is here regression. You click on regression, click OK. So it asks you again the model, what regression do you want to do? I want to get the X value. The X, again, is going to be, the Y axis, sorry, is going to be cropland. And the X is going to be the number of people. And that will be it. contains non-numeric data. So that means that it doesn't like the first row. So that means that we actually need to select the range. So the y-axis goes from D2 all the way up to D444. The x values are from C2 all the way up to C244. Click OK. And now Excel returns these values to you. Again, the R square is 0.001, so basically it's like there is no correlation there whatsoever. And the very important thing for you to realize is this value here, which is the significance value, the p-value. Here, this p-value is the other thing that is important to you, is 0.25. So basically, the 0.5 just tells you that this correlation is really within the expectations of something that you will expect to see by chance. So basically, there is no correlation there whatsoever. So what's going on here? Obviously, what's happening is that we are running this regression analysis on the data on the raw data, right? So what we need to do is log transform these variables that we just created there. So for us to do that, we are going to type equal log. We're going to log transform that value. So this is going to be the log of population. And we're going to calculate the log of cropland. It's going to be equals to log. So here we just have calculated the log of the population density on this cell for Mongolia, and on this cell we have calculated the log of the cropland for Mongolia as well. So you select those two cells, double click there. That will calculate the log for all of your population densities and croplands. So we can repeat that analysis again. At analysis, we're going to do the regression. We are going to select now is no or range Y. Again, it's going to be cropland, but now we're going to select the log scale data. And for the x-axis, we are going to select the population data, but now log transform. We click OK. And now here you get the results of that regression analysis. Again, the R square, as we saw before, is 40%. But the important thing for you to see is this p-value here, right? So now you can see that this value is minus 29.4. So it's super small p-value. And any p-value that is smaller than 0.05 is something that we consider to be significant. So whatever you are analyzing is significantly different from whatever you are testing there. So that's the way to interpret that p-value there. So this is the way in which regression analysis is done in Excel. Again, you can just get the plots here, the equation, the R square, and you can also get the significance of that regression with this. Now what we're going to do is we're going to try to do the same thing. We are going to try to do it in R now. As you can see, this took us like a very long time to get up to this moment to get this regression analysis done in Excel. Now what we're going to try to do is to do the same thing, but we're going to do it in R. Let's just close Excel. Let's don't save any of the things that we just did. Now, unfortunately, you at times are still gonna need to use Excel, right? So these are the files that we just downloaded from the World Bank. We need to make this data into a format that you can read in R. So for that, let's open up the folder, the file again of the GDPs. So in in R, you cannot have these empty spaces at the top of your database. Excel is just gonna get confused there because it just doesn't know what all of this stuff means. So the first row of a database in Excel needs to be the names of your columns. So what we can do here is right click and delete that, right? So that now will be a database that R can do, that R can understand. So we can just close this and we're gonna save it now. So this is the data on cropland. We're gonna do the same thing for the data on population. Again, you need to delete these top rows there because those empty cells, right click, delete, right? So now you have the first row, as you can see here, has the country names, the names of the names of the columns that you want to import into R. Then save it. All right, ready to go to R. So I assume that at this moment you have already installed R in your computer. So just click on the icon, open R, and this is pretty much the console of R. It is amazing, really, that this is the most powerful software that exists today in the world, and it's just a white screen. You can just not really tell anything from this screen, but amazingly, this is a program that pretty much can do anything that you want, and it's kind of remarkable, super scary, really, that it's only a white screen. So now let's get started here. Let's just do a quick background in R. In R, you can create something that is called variables, right? So for instance, I'm going to create a variable that I'm going to call A, and I want that variable to be equals to 1, right? So I click enter. Now A is going to be equal to 1. So if I ask my R, what is A? I just click A and type enter. It will tell you A is 1. Let's enter another variable. We are going to call that variable B, and we're going to call that variable is going to be equal to 2. Now you click B, R will tell you B is equal to 2. So now R has two variables that has stored to this moment, A and B. So you can just, for instance, type what is A, variable A, plus variable B. And then you click enter, that will tell you that's equal to 3, right? So that's kind of one of the principles of R is that you can create variables, and those variables will get they can get different numbers. They can be databases, they can be tests, they can be whatever the hell you want them to be. So here, what we want to do is to import two databases that we just got from the internet. The first one is the population database, and we're going to call that pop. That's going to be equal to bring data from CSV files. You type read.csv, open brackets. Now you go to the folder where your data is located. You right click on it. You need to get the name, the whole location of where it's located. You copy that. Go back to Excel and paste it there, right? So here you had, it's located in C, in Camilo Mora, downloads, and this is the folder. Put this /. Now what we need to do is to get the name of the file. So right click on it, on the name of the file. You see this thing rename. Now you can select all of the name of the file, copy it. Now go to Excel and paste it there. Close parentheses. So what we have here is again the name of the direction where the file is located, and this is the name of the file. Right? Now let's push enter there. It tells you there is an error, right? It took me early on when I was working in R about seriously like a week to figure out how this error came out. Turns out that Excel doesn't like this these signs here, the backslash, these ones here. So you need to delete that and put the forward slash. So you need to replace all of those forward slashes there. Now, because this is a test file, you need to put this between quotations too. Now you click enter, and now you type pop. It gives you all of the database that you extracted from Excel. All right. Obviously, you can see that something was weird here on this database. It didn't imported the columns correctly. So we need to go back to Excel. Let's go back to this population file. So we damaged the file. All right. So this is very interesting. This is an error that happened there. So when I save the file, when we deleted the top rows and we saved the file, one thing that we failed to do there was to tell Excel to save this as a CSV file. That's the reason why now all of the columns are merged on a single cell. So it's good that we found this error so that if it happens to you, you know what to do. So obviously what we need to do is to close this. Don't save it. So go back to your downloads folder, delete those two folders that you created earlier, and let's unzip the files again. So that unzip that file. So unzip this other one. Click OK to unzip it. Now the two zip files were unzipped now. Let's go back again. Open up the first one, the one on population. We're gonna delete the empty cells at the top. Delete that. Now when we save, click Save As. And here, see, this is the error that we had there. It saved the file as a Unicode test. So in reality, what we want to do is to select CSV, which is comma delimited. Basically, what it means is that every column in this database is going to be separated by a comma. And that's what R and many other programs will use to separate the data into the different columns, right? So you click Save. We're going to call it, let's put a name to it. It's going to call it population. Say that it asks you that you are going to be saving this as a CSV file. You click yes. Let's close it. Let's not save it because we already saved it. Now let's do the same thing for the other file, the one on Cropland. Let's open the bigger file. Let's delete the empty rows. Here, when we save it, we are going to save it as a CSV file, comma delimited, and we're going to call this one crop, right? And we save it. Again, it tells you that it's going to save it as a CSV. You click yes, and then you close this. Don't save it because you already saved it. We can close Excel now. All right, so let's go back to our Excel, to our R. So this is again the link that we just created, but here we changed the name of the file to just pop. You remember? Just replace again and click enter. And now we can see what pop is. Now you can see that all of the data was entered correctly there, right? Now, Obviously this probably is going to fill up your screen. So another way to look at this database, just the top one, is to type head, open brackets, pop, right? It's just telling you, show me. Head is a function that allows you just to show you the top 5 rows of every database. Obviously the pop is the variable that now contains the human population database. So there you can have it. So this is the country name, the country code, the population indicator, and the country all the way up to 2015. Now let's do the same thing. Let's import now the data on cropland. So we're gonna generate another variable that is called crop. That's gonna be equal. Again, we open quotations. We go to our folder where the cropland is located, which is this one here. We copy the entire link. We go to Excel. We paste it there. Then we put the /, and now we need to put the name of the file, which is this one, crop. So we can just type it since it's very brief, crop.csv, and then you close quotations, and then you type enter. So there's an error there. So I hope at this moment you can see what the error could be. Obviously the error is the fact that we are not telling R to do anything there. Sorry, the /. So let's just remove the slashes. So remember, they had to be // right? And then you click enter. Now let's type crop, and saying that crop is that test. So, but how is it that we don't get the database though, right? So before you type pop, the variable pop, which is the one that we created with population, you get the data, but on this one crop, you only get a name. Obviously the reason is that we haven't really called the database that is located in this link here. So for that we type again crop is equal to read.csv. This is the function that allows you to bring all of the data that is located on that internet link. So you can either copy this, copy and paste it there, and close your brackets, click enter, and now again let's type head equal crop, close brackets, and that gives you the database on cropland, right? So that is one of the ways to import data. There is R comes already with some default functions like the ones that we are just using. However, many people around the world is working in R and they are making their own functions. So sometimes those people make these functions available as something that is called libraries, right? So you will find sometimes you find yourself looking for something that R doesn't do. So what you need to do is to find out if somebody else did it and use the libraries that people has made available to you. So the way to do that, again, if you go to the internet and Google for R, use the letter R. Right here, you can get the web page of R. And here this where you can download all of the different things that R has to offer. You can go to any country. You are located on a specific country. You can just get that from the web. And here you can download R itself for Windows, Mac, or Linux, but you can also download packages. The option right here, packages. So here you can see the table of available packages sorted by publication day or by name. So R offers a gazillion types of packages that allow you to do pretty much anything in the world that you can think of. Somebody already deal with that and they make those packages available to you, right? So how do you get those packages into R? Well, it's very simple. Here we're going to be using a package called data table, and it's a package that is super nice to handle huge databases. So how do we bring that package into R? R obviously doesn't offer it in the installation, the first installation, so that means that you need to install it there. So you go to packages, you have the option there that is called install package. Here it gives you the names of all of the servers in the world that had packages of R. We're going to use the first one, the clouds. I mean, here in the United States is probably the best place that we can go to. Click OK. And here we get the list of all of the packages that are available on that server. So we're going to scroll down and we're going to look for data table. So where is data table here? Data. There. Data.table. So you select it and then you click OK. Obviously you need to be connected to the internet and are already loaded that package into your computer. Usually you can you go to R in documents. In your documents, R, when you install R, it generates this folder here called R. You double click on it, double click on this library, and this is where R will put all of the libraries for you. So these are all of the libraries that I had installed in my computer, and you can see data table should be somewhere in there. Okay, maybe not on this one. What about on this one? So right there, the folder data table. So the file that we just downloaded, R put it there. So anytime that you want to find out something about where R is putting your packages, it's usually located again in this folder called R. And here in my computer, I had installed 3 versions of R, and that's the reason why we had different folders there. Let's just close this, and that's where R is loading your. So the package is now safe in your computer, but you haven't loaded, right? To load the package, you type the word library, right? And the name of the package, library. The name of the package is library data.table, close bracket. So now it tells you again here that the library data table has been loaded. Now, what we need to do is to open up those files again, the ones that we just downloaded. We're gonna here on crop, instead of loading the database as a CSV file, we are gonna load the file as a data table. And to do that, all what you need to do is to replace that read.csv. You are gonna call it, replace it for fread. And again, fread is the function that data table uses to import the data into R. So that's your database crop there. Let's do the same for population. So right here, this is the database on population when we load it. And we're gonna type fread. fread. Click enter. So now we had 2 databases that is called pop, and now this is as a data table, and we have a database that is crop, which is the data on cropland. So you remember, okay, now they are separated. What we want to do is to bring them together, right? So here we need to use something that is called set key. So basically we need to tell the database, data table, is what is the name of the column that you want to use as a key, right? And that's what is later on used for you to merge those 2 databases together. So you type set key, you select the name of the database first, which is pop, and then enter the name of the column. So we want this. Okay, here we had another problem, that the columns, that the data that was, when it was saved, sorry, when we bring it into R, it didn't select the first row. You see that? The first row, it was something entered by R directly. Well, in reality, we wanted the first row to be the names of the columns. So how do we fix that problem? Again, it's very good that we are countering those problems here, because for you to discover those problems later on is going to be a nightmare. So what we need to do is to tell data table, the function data table, to import the first row as the name of the columns. So how do we find that out? If you type the question mark and then you type fread, which is the function that imports the data, that will allow you to get the information for that function. So again, it will open right away automatically in the internet all of the information for you to use that function fread. Here again, this is the help function. So you have the function there, fread, which is part of the package data table. It describes to you what it does, how to use it, the different parameters that you need to enter to it, and at the bottom of it, there is multiple examples that you can run to use that function. That's one of the coolest thing about R, is that it already comes predefined with all of this stuff for you to use there. Anyway, the problem that we had specifically in our case is that when we were entering that data into R, the first row that was called was not the first row on the Excel sheet, and we want R to know that. So we look here over the instructions. So fread, it has the input, the end rows, the header, so here, if you look at the different things that you need to enter, header, does the first data line contains the columns? The files accordingly. So header, we need to make it to be true. So if we go back to our Excel, to our R, when we loaded the file with read function, which is this one here, we need to say header is equal to true, right? And then we type pop, and now you can see that the first row now is the names of the columns. So we need to do the same thing for crop. So it's going to be header equals true. And now if we type crop, you can see that again, the first row is the names of the columns. So let's just summarize quickly there what happened when we were entering the data from Excel into R, or from CSV into R. R was taking the first row, was not taking the first row as the names of your columns. So that thing there that we use, the header equal true, just tells R, okay, I want you to select the first row as the names of the columns. All right, so now we can go back again. So we had two databases there. One is crop and the other one is pop. So these are the two databases there. Now what we want to do, we want to select just the year 2010 from each database. We don't really want to have all of those other years. So how do you do that? Well, I'm going to give you my trick here in case that later on you want to do something specific. So you go to the internet, you can say how to select a column from a data table in R. Just ask the question, you click enter, and here it is. So the first help, it tells you select multiple columns into data table. Let's look into that. So again, it gives you, we had a data table. How do I select different columns? You scroll down So here is one way to get just to the columns that you want, right? So you had a data table that has 3 columns, A, B, and C, but in this case, this guy only wants the columns between 2 and 3, right? That's one way to do it. It's another way to do it. There are multiple ways for you to do this stuff. I just want to find out another one that I saw subsetting maybe. Okay. So here is another function, another way to get those columns. So let's just copy this. Let's go into our Excel sheet, into our R thing. So keep in mind that dt, in our case, is the name of the variable, which is called pop. What are the variables that we want? Well, we want to add the country code, can delete all of that, country code, and we also want to add the year 2010. Then you close your quotations. So you can see that the function there alone just gives you your population. From your population, it gives you the names of those two columns, country name and the year, right? So we obviously want to generate a variable for just that. We're going to call it pop 2010. That's going to be equal to these 2 columns that we just selected there, right? So again, if we type pop 2010, click enter. Again, now it's a database with just 2 columns, the country code and the data on I think this is the GDP. Obviously, we don't want it to be called 2010. Now we can actually put a name to it. So the way to change the name is set names. From pop 10, you select the name of the database. Then you enter the name that is there, 2010. But we are now going to call it pop 2010. Then you close brackets, click enter. So actually it's not set names, it's set names. There. So the problem that I was having there is the fact that I was entering 2010, the old name of the column, this column here, I was entering as a name. The reason why R, by the way, R differentiates between names and numbers, whether they are between quotations or not. Like in this case, for instance, if it is in between quotations, R is going to think that that's letters. If it is without quotations, then it's going to consider whatever is there as a number. So in this case, I was entering a number, so R is just getting confused because there is not a number for that name. This name obviously had to be test. So that's the reason why now when I put it between quotations, it allows you to do that. So now you call the function pop. Sorry, it's pop 2010. You can see now that I have the country name and the population for the year 2010. All right, we want to now do the same again. But we want to do it for cropland. Right, we want to get from the database cropland, which is this one here. Instead of pop, we are going to call it crop. We want to take from the crop database the country name and the year 2010, and we're going to change the name of this variable to crop, the crop 2010. Click enter. Now we have a database that is crop 2010, and again it has 2 columns in it, the ones that we just selected there, which is the country name and the year. And again, we want to replace this year for maybe something that is more indicative of what is on the column, which is the cropland. So we're going to use set names. We select the database. Between quotations, we put the name that we want to replace, which is 2010. And we want to replace it for crop 2010, right? So now you go and look at the database cropland 2010, crop 2010. Again, you had two databases there, two columns there, country code and the column with the cropland for the year 2010. Again, you call pub 2010. You get those two databases there. So anyway, what we had up to this moment are two databases that are separated. On one of them you had the country with the populations, and in the other one, which is this one here, cropland, you had again the names of the countries with the croplands. What you want to do now is to merge the two of them. The first thing that you need to do is to set a key, right? So that you know, so that Excel knows how are you merging this stuff. So you're gonna enter a key for the first database, and that key obviously is gonna be the country code. Again, I think that we need to put that maybe between quotations. And we are gonna enter another key now, but for cropland 2010. So now both of our data tables had a key. So now we are gonna generate another variable, which is population and cropland together, and that's gonna be equals to merge, and we are gonna merge population and we are gonna merge cropland in 2010. Then you click enter, and that pretty much will do the merging for you right away. So now you can see all of that effort that was done in Excel, remember, with the VLOOKUP and all that kind of stuff. Excel did it for you on the fly here, and what it did, it merged your database on population now with your cropland, and now you are in business to run a regression analysis. In Excel, the regression analysis is done with the function lm. Type lm, you can enter population cropland, the x value, and then you type that symbol there as a function of population. You click enter, close, it tells you there is an error there, right? Well, it turns out that in this moment Excel doesn't really, R doesn't really know what crop 2010 or population 2010 is coming from, right? There is no variables that are called like that. So in the function lm, we need to now tell it that these two variables come from this database called population crop. Then you click enter. Okay, let me just look at something quickly here. So I think that we're having an error there because of this NA stuff. Alright, I'm gonna check something out quickly here. Bear with me here, LM. I'm gonna do pop crop. has to do something with these NAs here. So welcome to the world of R. This is where you're gonna spend a lot of time and you go into this kind of stuff, figuring out some of these tiny details. Okay, here is where the error is. So basically, when we were entering this database, somehow the population database is being considered by R as a character, while the data on population is a number. So obviously what we need to do is to transform this data on population from character to numeric. So again, you go here, Google is your friend. You type how to transform, to convert data from character to numeric in R. So here are some of the functions there, how to convert data column to numeric. You click on it. Somebody asked that question already, so how do you change that? So here is one way to do it. Just copy that line there. Okay, I like this one. This one is actually neater. So you go to Excel, to R, sorry. You type what you just copied there. So really the problem that we had is with this data, with this column population 2010. So you select the name of the database, which is population crop, which is this one here. On the other side of that $sign is the name of the variable, which is population 2010. Just replace that X for that population 2010. You click enter, and now you have that as numeric, right? So what we want to do here is to just select that column though. So what we are gonna do, there's multiple ways to do this. So we're gonna create another database, pop a cropland numeric. It's gonna be equals to a data.table, and that's gonna have the country code. We're just gonna create a new data table here. Country code. We are gonna have also the population 2010. Let's just do the cropland first. And it's gonna add the population database there, right? So here, let me just explain quickly what I'm trying to do here. What I'm trying to do is I'm gonna create a new data table that has just those three columns, but now we want to convert the data on a population from a number from a character to a number. So the way to do that is we type a new name for the new variable that is gonna contain your data table. The first variable on that data table, we are gonna call it country code. country code, that's going to be equal to the database population, and we want the country code column. Now we want also the cropland. It's going to be called crop 2010. Crop 2010 is going to be equal to the name of the database, which is population crop, and it's going to be also the name of the column, which is cropland 2010. Now the one that we want is population 2010. I'm going to put a comma there, but the population 2010 now is going to be this transformation here, in which it takes the data on population 2010 and takes it from a character, and now it converts it to a numeric, right? So we go there, that's equal to as numeric the population, and then we just close the brackets there, click enter. Shoot. All right, man, this is hard stuff. Let's just go back to this. Let's look, how do we transform a database? Okay, this one could do it too. Just check it out. Okay, so we're gonna add data. Just gonna generate a variable data1 equal to transform D, which is population crop. The name of the variable, which is population 2010. And we want that to be numeric. All right, so now we had data1. Let's see what data1 is equals to. All right, so again, the way for you to find out the different types of data on the columns is using the function sapply. You type the name of the database, and then you type class, and that will tell you the different forms, the different data types on this database one. So in database one, the country code is a character, which is fine, it's just the name of a country. This column, population 2010, is a numeric, and cropland is numeric. So now we have the two variables that we want to correlate as numeric. So let's just go back again and try to do a regression model. LM is equal to population, so cropland is the correlation that we want to do as a function of population 2010, and our data is equal to this database that we created here called data1. Then we close it, click enter, and there you have it. Woo. So again, the correlation between cropland and population is, these are the coefficients. Actually, another way to do it is to enter that as a variable. So let's just call it reg, and that's going to be equal to the regression model that we just copy there. And now you can type summary regression, and that will actually give you much more information about your linear model. Again, if you look at the regression line between cropland and population from the database one, you can see this one here is the famous intercept, and this will be the slope, and this is the significance. Here is 0.5. Again, if you remember, this is the same value that we obtained in Excel when the data was not transformed, and here you can see the p-value of PV1, and the regression square, the R square, is this one, 1.006. So there is no correlation whatsoever between cropland and population. But again, keep in mind that this is the data on the linear scale. So what we need to do is to transform, to run the same regression, but we are going to do it in a log scale. So to do that, you just type log square 20 crop 2010, and we are going to correlate that against the log of population 2010, and then we click enter. And now we can look at the summary again, and now you can see the different parameters here. Let's interpret this again. This is the formula, and basically we are looking at the regression between cropland and population using the logarithmic scale from the data 1. These are general indications of your variables. Here are, this is the intercept, it's negative minus 3.4, and this is the slope of the regression model. Here it gives you the R square, which is 0.4. You remember from the earlier part of this tutorial, that's about 40% of the variance in cropland can be explained by variation in the number of people as a function of those variables being related in a logarithmic way. And this is the p-value there, right? So as you can see, the p-value is 16 zeros 0.2. So this is a very significant regression. So from this you can conclude that indeed there seems to be a very strong regression between the number of people and the cropland that is used on different countries. 40% of that regression is explained by population, and is very significant. So there you have it. This is how to do a regression analysis in Excel and in R. You can appreciate really the difficulties of doing this on both types of programs. I'm very glad that we actually encountered some problems in R. You are going to be facing those problems all the time, and in this case, Google is your friend to fix many of these problems. If you had a question, just formulate the question as you will ask it to me, and I'm sure that Google will answer that question for you. All right, there you have it. See you next week.